Hello everyone, welcome back to Sujit Analytics. This is a continuation of Power BI tutorials. This tutorial, let's understand what is the difference between star schema and the snowflake schema. Because in the real world scenarios, choosing the right schema for your data model is very important because it affects the performance of the model, usability, and the data consistency and the maintenance. So let's understand how star schema and snowflake schema look like. So this is the data model. In a model, I have multiple tables: date, store, customer, product, in a sales. So this date, store, customer, product are the dimension tables, and this sales table is a fact table. So in the previous tutorial, I have explained what is dimension tables and fact tables. I recommend you to watch the tutorial. These are dimension tables, and this is the fact table. Now this model forms a star schema. Why are we calling it a star schema? Because the star schema, the model consists of multiple dimension tables around a single fact table. One second. So why we call it star schema? Because around a single fact table, this is a fact table, we have multiple dimension tables. These are dimension tables, these are fact table. So a fact table is surrounded by multiple dimension tables. So why we calling it as star schema? Because entity relationship diagram stimulates a star. So when we draw a diagram, create a star. So it's similar to a star. That's why we call it as star schema. So in star schema, we have multiple dimension tables around a single fact table. So, when it's coming to snowflake schema, these dimension tables are divided into sub-dimension tables. So these dimension tables like customer, store, date, if, if applicable, product, or sub-dimension tables. So in Snowflake schema, we perform Snowflake schema when based on our data. Based on our data, we choose the star schema or Snowflake schema. Suppose if I go to our data in the products table, we choose product key, product name, category, and product type. So when it's come to department, here the kitchenware belongs to home goods, the accessory belongs to home goods. So this data is repeating multiple times, which is creating data redundancy. So to eliminate this redundancy, we created separate dimension tables for this category and department and establish relationship between the tables to avoid data redundancy and to improve data consistency. The same way, the store table, when we see here, the USA country is repeating two times for the West region and the East region for these two products, for these two stores. So again, the data redundancy. To avoid this, we create separate tables again for the country region. So let's create separate tables for this country region and also the product category, separate category. For that, we have to go to transform data. Let's come to product. Now these two are repeating two times. That's why I want to create separate product category table, which stores category and their respective department. For that, I'm creating a copy, duplicate, name it as product category. This product category table, I want only category name and the department name. So I want to delete marketing product category. and product name, remove rows or remove columns. Sorry, so the two name is removed. Now I want to ensure only unique values. For that, remove duplicates. And there are no duplicates. That's why we are not able delete any row. For this table, I want to create a unique key, unique identifier. So I can connect to my product table. Here is my product table. So I want to create a unique key. So I can connect to my product table. For that, I'm creating a unique column for this table. For that, I'm going to add column, add an indexed column starting from one, which creates a unique index for each row. Rename as okay, rename as category ID. So if we want to connect to products table to category table, so the common column is so we have to ensure this category ID is present in this products table. This product table. So to for that I want to do a merge because I want this product category ID in this products table. So I can create a relationship between these two tables. So to perform merge, I need to go to home tab, merge queries, this product name, and merge with the product category. Mm, Common column is name, department, okay, to perform merging. So now able to get the product category table. Just expand. I want only category. Now we have a separate category ID for this table. Now we can delete these two columns. Remove column. Now we have the relationship between two tables based on category. Category ID, category ID. Can rename as data ID. Next one is come to source table. Now the country is repeating for two times, which has data redundancy. So I want to create separate region table, region country table. For that, again duplicate the store, rename as region, region country. Stores table, in the region table, I want to the region name and the country. I don't want store name and store key. No column. Again, create a unique identifier for this table. For that, add column. So why we are creating unique index for this unique column for this table? Because I want to uniquely identify this region and country table. So I can connect to other tables. Again, the indexed column from zero. Name as uh, region ID. You can create from any number. Default, we can create from zero to zero, from zero or one. So we can create a specific criteria. Region ID, here in next column. We can choose from zero, from one, or we can create a custom range, starting index and the incremental value. Cancel. In the stores table, I want this uh, region ID. For that, I want to perform merge. The previous tutorial, I have explained what is merge queries and append queries. Make sure to watch if you have any doubts. In store key, want to merge region, country. So common column is region name, country name. And I want to only region ID. Remove these columns. We don't need this column because we have already separate table in columns. Now we have separate tables for store, separate region, country, product, product category. Now let's load into the data model. Taking some time. Okay. Now we have separate tables. It automatically detected the relationship between these tables. Product category, this region. Region belongs to the store table. Follows one-to-one relationship. One-to-one relationship. So this is the Snowflake schema. Why we are creating a Snowflake schema? Because in the stores table and the products table, we have data redundancy. The for a product or for a store, we have data is duplicated. To avoid that duplication, we have created a separate normalized table. These are the normalized tables. So before Snowflake schema, we have the denormalized tables. Means denormalized tables, we have data redundancy. But now the data redundancy is not there. Oh, because we have created a separate tables. So the data is consistent now. This is nothing but a Snowflake schema. We are dividing dimension tables into sub-dimension tables. So like this is the star schema and Snowflake schema. Like when we have to choose star schema and when we have to choose Snowflake schema means if you want the performance of the model is good, very faster, choose star schema. But if the model wants the storage rather than the performance, you have to go to Snowflake schema. So I have given the difference between star schema and Snowflake schema in Excel file. Now we can see here this is a star schema, Snowflake schema difference. This is a structure. This structure star schema fact tables link directly to the primary dimension tables. The Snowflake schema fact tables link to the dimension tables, which is turned into sub-dimension tables. This is sub-dimension tables. These are dimension tables. Now here see. In star schema, dimension tables are wide and flat with descriptive data. So in star schema, data is denormalized. But in Snowflake schema, data is normalized to avoid data redundancy. Here see. In the star schema, the data redundancy is high. The Snowflake schema, the data redundancy is low. When it's come to performance, report performance very faster because in star schema we have less dimension tables, requires fewer joins to perform dash calculations, create visualizations. It is very faster. But in Snowflake schema, yes, that's why it's slow. So in the storage, the star schema use more storage due to repeat dimension data. Due to data redundancy, it takes more storage. Snowflake schema take less storage due to data is stored in separate normalized table, which is unique. And usability is high. Here, the usability is lower. The primary use case when we have primary star schema, when performance and simplicity are the top priorities. So when performance is important, go for star schema. But when storage efficiency and data guarantee is important, go for Snowflake schema. This is about star schema and Snowflake schema. I hope you understand. If you believe you learned something today, don't forget to give a like and share with your friends who are learning Power BI. That's all. I will share this Excel file in the description. Make sure to download and also understand what is the difference between star schema and Snowflake schema. Try to create separate tables for this dimension tables. So that's all. Thanks for watching. I'll see you in the next tutorial.